So this week's topic is how agriculture impacts water quality, water pollution, all of those types of issues, and or not agriculture, I should say food production in general. But we're going to focus a little bit more on water treatment this week and a little bit less on the agricultural impacts. I think we could come up with several examples of ways that agriculture could have an impact on water quality, from runoff from livestock manure to all of the vehicles that we use out in the fields and transportation. All of those things create pollution. But we're going to focus on water treatment. So think about some of these questions as we go through this. What are the biggest problems with water quality? What factors affect water quality? Are all substances found in water harmful? How do you think scientists determine the health of a body of water? There's all kinds of things that we can look at. So why do we need to clean our water? Which one of these pictures of water would you be willing to take a bath in? I'm guessing most of us would feel very comfortable with 4, maybe less comfortable with 3. Which ones would we drink? Guessing most of us would be over here at 4. Which ones would you cook with? Which would you brush your teeth with? Now, if I said you may only choose each bottle once, what would you say? What would we use bottle number 2 for? Or bottle number 1? So if I said that we could treat these waters and make them look like bottle number 4, then we might be a little more willing to use them. Okay. Now, interestingly enough, look at this. Bottle number 1 came from a very clean river. Bottle number 2 came from a semi-clean lake, but it has some bacteria and some silt, some soil from the bottom of the lake mixed in. Sample number 3 came from a city. This is what comes out of your faucet. Sample number 4, which appears to be very, very clean, is actually water that contains deadly bacteria. We can't see bacteria, so we have no idea that the water contains that. So it's important that somebody is paying attention to what's in our water. Okay, I'm going to go through here and skip ahead. Water is essential to life. We know this. We know that the human body and all living organisms require water in order to function, but we take it for granted. It's incredibly polluted, and there's a lot of problems with fresh, clean water supplies around the world. But how do we get that water clean? Okay, that's what we're going to focus on this week. So water quality determines the health of ecosystems, human activity, and human existence. It supports all of us. All living organisms need water. Without water, the world would be a dry desert land with no life. Okay, so this is an extremely important topic. How does this fit into food chemistry? Let's think about all the chemicals that we've talked about. Those chemicals often end up in our water as pollutants, and so now we're looking at maybe how could we remove some of those chemicals or pollutants. Water creates the weather that makes life possible. Whether it's the precipitation that we experience, the rain, the snowfall, all of those types of things, the clouds, the sunny days, all of those things are impacted by water. What are some terms that we can use to describe water quality? Water quality is an array of chemical, physical, and biological measurements that define water quality. Okay? Chemical would be testing for things like ions in the water, charged particles. Physical are there flakes of something in our water? Is there residue in the water? And then biological measurements. Bottle number 4 looked like the bottle of water that every single one of us would choose to drink, but it said that it was loaded with bacteria. Biological measurements are looking at those things that we can't see that are living in the water supply, viruses, bacteria, protozoa, all those types of things. Potable water is water that's safe to drink. This is water that comes out of a tap that has been deemed safe to drink. Safe water can be used for cleaning and bathing, but not drinking. These terms are sometimes confusing. I've seen examples of this in our school and in our community. There's a there's a water faucet on the wall in the cafeteria at the high school. And it's an old one where if you pushed your glass underneath it, it would fill it up with water. There's a sign right on there that says not safe to drink. It's not potable. I'm not sure what's happened with that faucet over the years, but somebody has gone through and done testing and determined that that water is not safe to drink. So there's a sign there. A couple years ago at the Fox Lake Golf Course, they had problems with their well, and they kept finding that there were small traces of E. coli in the water. So they determined that that water was safe as far as you could wash your hands with it and do some of those kind of things, but they wouldn't let people drink the water or use ice from the golf course. They had to haul in all of their own ice. So those are important terms to pay attention to. So how do we monitor what is potable water and what is safe water? Okay, so the U.S. Environmental Protection Agency is the governmental group that is responsible for monitoring our water. They're looking at reducing pollution and protecting the environment all at the same time. They set maximum levels for the 90 most commonly occurring water contaminants. So they determine how much is okay to have for each of the different contaminants in our water. Okay, so what is water pollution? Sorry, I'm going back and forth here. Water pollution is any contamination of water with chemicals or other foreign substances that are detrimental to human, plant, or animal health. Nearly 2 billion people drink contaminated water worldwide. That's a huge amount. That's alarming. Non-point source pollutions are widely spread source of pollution that can't be tied to a specific origin, like acid rain, as an example. We can't tell exactly where the pollutants in that acid rain, came from. Okay, point source pollutions, which should be coming up here on our screen. Sorry, it's not coming up, but we can tell a specific place where the pollution was caused. We'll continue going on here. Okay, so different types of pollutants. There are pesticides. Human waste can cause pollution. Industrial waste, all of the products that we use generates waste when those products are produced. And those wastes oftentimes run out in the water supply. Chemical waste, factory processes involve toxic chemicals and strong acids, and so the EPA is constantly measuring how much of that is being emitted from factories. And then stored chemical waste in barrels cause non-point sources of pollution as well. Why do we need to treat our drinking water? All of those things that we just talked about, industrial runoff, that's going into our water supply potentially. Agricultural runoff, things, the chemicals used in the fields and used for livestock production. Road runoff, residential and urban runoff. Think about all the fertilizers used on lawns and all the pollutants in big cities. Those things are all running off. So water treatment process. I want to go through these processes with you. This is what a water treatment plant would do. The first step is raw water intake and screens. Okay, so the raw water comes in, and there's something called coagulation and flocculation that occurs. When the raw water comes in, they add a coagulant, and they mix that coagulant with the raw water. And basically that causes all the particles to kind of clump together so they're easier to strain out. There's sedimentation, which the picture's not showing up there. There's a settling basin, so this is where the water goes and everything kind of settles out. They're able to filter the water through a filtration system, and it catches those larger particles. And then disinfection. Fecal coliforms are things that are carried in feces that would be disinfected and taken out that are neutralized at that point, and then storage and distribution of the water. So this is not an assignment that you need to do right now, so don't worry about that. But we're going to make our own water treatment filtration systems using items that you have at home. Okay, so your next step is to watch the video where I walk you through the lab to create your own water filtration system.